All right, so it's still not factorable, so what am I going to do? We're on the pretest. This is problem 3B on pretest number 2. All right, so what am I going to do? What? I need sine over there, yeah, that's a good idea. I'll move sine over there. Anytime I've got squareds in my equation, I like to have it set equal to 0 for sure. Can't factor because I have 3 terms and they don't have anything in common. This is really messing everything up, right? Change it. Oh yeah. What can I change it to? What's cosine squared?
Sine squared x plus
1 minus sine squared. Now remember, kids, there's a lot to remember, okay? I agree with you. There's a lot to remember. What you absolutely have to remember is sine squared plus cosine squared equals 1. Once you have that in your brain and you can write that down, then you can start looking at it in different orders. What if you brought the sine squared over here? What would that equation say if you subtracted that over here? Wouldn't it say cosine squared equals 1 minus sine squared? I'm not asking you to memorize every version of every formula. What I'm asking you to do is memorize the formula and then be able to write it down and move stuff around. Not from memory, but just by doing arithmetic. So cosine squared is 1 minus sine squared, so that goes in right here. That's what we typed in right here. Right there it is. So now I've got an equation. Well, it's still a mess, but at least it's all sines now. So I have negative 2 sine squared minus sine plus 1. Right? Now, I think I'm going to factor this. Just like I factored that tangent thing a while ago. But here's the issue. Somewhere in my 62 years of life, I developed an aversion to factoring with a negative leading coefficient. I can't do it. So my first step is going to be to divide the whole shebang by negative 1. You do not have to do that. That's a Lisa Ford thing. I can't deal with that negative. So I'm going to divide it out. It's perfectly legal. Divide everything by negative 1. Now I think I can factor it. I know I'm going to have a 2 sine times a sine, because that's how I'll get 2 sine squared. I know I'm going to need 1 times 1, because that's the only way to get 1 when I FOIL. And now I just need to figure out, I guess that's plus and that's minus. Because when I FOIL that out, it gives me a positive sign in the middle. Okay, so that means sine equals 1/2 or sine equals negative 1. Agreed? All right, here we go. Don't need a calculator for this problem. Where's the sign negative? Sine is y. Y is negative down below, so this is where sine is negative. And if the sign is, wait, was that positive?
Yeah.
Oh, well then I know don't want it to be negative, I want it to be positive. Where is this one I want to be negative? Where is the sign positive then? Obviously, 1 and 2. Sorry about that. I don't know why I thought that was a negative. All right, so I'm positive up there in quadrants 1 and 2. Sign is y is positive up here. Do you recognize that angle? Well, you should. It's a 30, right? That's 1, 2, root 3. It's not a root 2, it's a 2. So that's a 30-degree angle, which in radians is pi over 6, because 30 is a sixth of 180. So one of my answers is pi over 6. What's the other one? What would this one be over here in quadrant 2? Pi minus pi over 6, which is 5 pi over 6. That's 6 sixths minus 1 sixth, 5 sixths. Now this one's a little bit trickier because let's say you tried to draw your triangles down here. In order for the sign to be 1, wouldn't these two have to match? Opposite and hypotenuse. And is that possible? No. So these triangles aren't possible for this problem. So if the triangles aren't possible, I'm going to have to look at my circle. And where is it that the sign is -1? Straight down, right? That's where the sign is -1. What angle is that in radians? 3 pi over 2. Yep, 1.5 pi's. That's no fun. 3 pi over 2. And that's the only place. So that's the answer to that one.
Yeah.
All right, let's try, trying to get into some more practice here. Let's try 6. We'll do A and B. Hopefully we have time. We'll do A and B for number 6. Okay, what do you want to do with the sine of 105? The sine of 105. Anybody have a thought? 60 plus 45, somebody said. That sounds like a winner to me. Does that work for everybody? Other choices for sure, but that is a good one. So then I look at my note card. This is the sine of u plus v. So sine 60 cosine 45 plus cosine 60 sine 45. Just doing the u and v thing off my note card. Okay, now what do you think you probably should do? Probably should draw these two triangles if you don't already have them memorized. And you might, I mean, you've done a lot of this, so you might have them memorized already. But if you don't, you're going to draw them over to the side, the 45 and the 60. And then you're just going to take the numbers from the pictures and plug it in. So what's the sine of 60? 3 over 2. If you're still messing this up, write SOHCAHTOA at the top of the page to remind yourself opposite over hypotenuse. Cosine 45, let's rationalize it. It's 1 over root 2, but I'm going to go ahead and enter it as root 2 over 2. Which, by the way, is the same as the sine. Those two always match, sine and cosine of 45. And then the cosine of 60 is 1/2. This looks very familiar. So multiply root 6 over 4 multiply root 2 over 4, and then go ahead and make one fraction out of it, root 6 plus root 2 over 4.
So we just have to know the double angle?
Mm-hmm. Plus the 8 that we knew before. The 8 that we knew before are mainly going to be used for your verification problem. We're going to have to do a verification problem. And we practiced a couple of those.
So which one should be on the new card? Just the ones that you're like adding?
Yeah, the adding and the halves. You don't have to. All right, let's do B real quick. And if we have time, we'll do one of the verifications up there at the top. So B says, find the cosine of 2A. All right, I'm just going to stop there. What is the formula for the cosine of 2A? Cosine squared minus sine squared. So I'm going to write down the formula that I'm going to be using. Now I'm going to draw a picture so that I get some numbers to plug into my formula, just like I did a second ago. Only this time I don't know exactly what the angle is, but I know it's in quadrant 3. Right, May? And I know the tangent is 3/4, but I'm going to be careful. In quadrant 3, that would actually be a -3 and a -4. Now, in this particular formula, it's not going to matter because you're going to square. But certainly if this were a sine problem or a tangent problem, that would come into it. So here we go. Hypotenuse would be 5, always positive. And then we'll plug them in. So this is the cosine squared minus the sine squared. So the cosine is -4/5. The sine is -3/5. Is everybody okay with that? And then we square, so we get 16/25 minus, I think, is that the same thing? Is this the same problem we did? I don't know. Looks like I got the same answer. Or maybe not, I don't know. It all gets jumbled in my brain. Does that look okay to everybody? Easy. All right, let's go back up and do one verification. That's proof from number 2. Anybody see anything in number 2 that looks like that's how you want to end your period today? Now let's go ahead and do, well, let's just do that first one. Actually, I think this might have been on somebody's quiz. I don't know if this class or the other class. I think something like this was on it. And kids did a great job with it. What are some things that occur to you when you look at this problem? You have to prove it. So you have to change one side into the other. So what are some things that that at least are like you're thinking about? Jack? Everything in the whole problem is a secant, except for that. And he is easily changeable to a secant. So what if we did that? What if we changed that cosine into 1 over secant? Remember, cosine and secant are reciprocals. So anytime you see a cosine, you can think of it as 1 over secant. Anytime you see a secant, you can think of it as 1 over cosine. That's a complex fraction. So I'm going to multiply everything by secant to get rid of the fraction in there, to get rid of this little fraction here. So now on the top, I have secant plus secant squared. And on the bottom, I have 1 plus secant. I'm going through this kind of fast. Everybody keeping up? You see what I'm doing? Do you notice anything now that you might try, Jack? You can factor the top. I can take a secant out of the top, and when I do, look at what I'm left with. There we go. All right, does everybody understand or have some kind of grasp of what's on this quest tomorrow? The problems that we have just practiced. Now, you have more practices here and the answers in Schoology. So if you want to spend some time practicing, you can. We also have office hours tomorrow. Monica came in this morning, we worked through some problems. Please feel free to do that, especially if you've practiced and it hasn't come out right. If it comes out right, then you're probably okay. All right, you guys can go, thanks. Okay, oh wait. Kirsten, I sent you an email, did you get it?
Yes, I'm about to send it to you like as soon as I can.
Okay, perfect, thank you.
Thank you so much.
Okay. All right, let me, we kind of spray the desk, maybe, yeah, right. Mask. I've been vaccinated, but most of these people haven't.
When did you get vaccinated?
I actually went to the speed limit and was in that drive.
I saw a video of that. It looked pretty cool.
I'll tell you what, it was the most efficient government-run thing I have ever participated in. The National Guard guys were there, and they were so wonderful. I mean, it was just like, they had traffic lanes, you had to get in your lane, and they stopped you, and they did each step, and you got little cards on your windshield, and then you got to the end, and they said, roll up your sleeve, and you're done. It was really very efficient, very efficient.
Did you go on the actual track?
That's cool.
Yeah, yeah, the waiting, they made you wait 15 minutes